Department of Earth Science and Institute of Earth Science, Sinica, Taiwan. And a kind of similar thought to Ching after I registered this conference. I thought that there will not be a lot of people who are familiar with my research topic, so I'm trying to design my presentation for those who are unfamiliar with seismology in the field of earthquake engineering. So I will keep my presentation short, and we have a time to discuss our results. Yes. So here is an outline of my presentation. I will present the introduction and motivation behind this study, and I will explain the objective, the methodology that we use to develop the model. Following that, I will present the key results and discuss, and finally we'll conclude with the take-home and recommendation. Northern Vietnam is a region of high seismicity with many active faults, with recorded ground motion magnitude range from 3 to 5. And however, there is potential for larger earthquake exceeding magnitude 6 occurs in the future. So in our analysis, we include 123 earthquake, 76 stations, around 1,000 ground motion recording, provide a good basis for deriving the ground motion model. Okay, let's discuss briefly the earthquake phenomenon and local site fact. As you can see in this figure, the earthquake release energy from their source and creating the seismic wave that propagate towards the site. And this seismic wave can be amplified by geological site condition, increasing the ground motion at the site. So for example, as you can see in this plot, the ground motion at the further soft side can be greater than the ground motion at nearby rock side. And this is a simple idea of how local site effect I would like to convey. Okay, so in general, there are three key factors that influence ground motion amplitude that include magnitude, distance, and geological site condition. In other words, the ground motion amplitude can be described as a function of magnitude, distance, and geological site condition. Any ground motion characteristic that are not modeling by these three factors will translate it into the error term, quantified by the standard deviation, which means that the smaller the standard deviation, the better the ground motion can be reliable and accurate. Okay, so the motivation behind this study is to estimate the mean, to reduce the standard deviation, ensuring the prediction. The primary objective of this study is to estimate the site amplification associated with the ground motion model. Just recap what I just said from previous slide. Site amplification are caused by the interaction between the seismic wave, the geotechnical property of a site. So any small change in geological site condition can significantly magnify the ground motion amplitude of the surface. So the challenges and proposed solution. One major challenge in site characterization is the lack of the VSLT measurement. To address this issue, we propose using the horizontal to vertical spectral ratio to characterize the side effect. The previous study, such as the Hosami, Hassani, and Makheo, have demonstrated the great correlation between the HOV and VS30 for various regions, validating this approach. Okay. Now let me discuss the methodology step by step. In step 1, we calculate the HOV spectral ratio for each side, and we derive the velocity profile. In step 2, we derive the permanent period and peak amplitude from the HOV data. In step 3, we propose 5 side categories based on the P0 and A0. The details of each side category are shown in this table. In step 4, perform the regression analysis to estimate the side coefficient, and this was done using the maximum likelihood regression via the mixed effect algorithm. And elaborating more on this step, we modify the SK14 model by subtracting its original side function and replacing with a newly proposed side function. This new proposed side function tied up with the local side effect is then eliminated as a part of regression process to capture the local side effect. And then step 5, we evaluate the model by examining the residual, comparing the standard deviation as shown in this plot. The model residual are concentrated around 0 with a 5 to 10% reduction in standard deviation as compared to the ASK14 model. Now let's look at the results. This figure shows the side amplification not to be significant for the side category 4 and 5, and moderate for the side category 3, and minimal to non-existent side amplification for side category 1 and 2. If we look at this figure, the new ground motion model fit the observation data well across a different magnitude in different period, significantly improving the over the SK14 model. And this figure shows the response spectra for various side conditions and shows that the side amplification effect notably under the spectral shape of the SK14 model, highlighting our importance of the side specific modeling. If we comparing the rock side model SK14 with the S1 model, we can see that the error term range between -0.2 to 0.2 across the period. For the S3 model, the error term even larger than the S1 model. Important of this is emphasizing the importance of our finding. Okay. Before I go to the conclusion, I quickly show this map. So the distribution of stations that category for 5 different site classifications for the northern Vietnam. So to conclude my presentation, this study estimates the side amplification using the HOV spectral ratio as a proxy for the side effect. The proposed side category reduced the misfit of an SK14 model, and local data improving the prediction. The standard deviation remained large due to a limited local data, increasing the capacity of the ZMM prediction with the right velocity profile to provide a foundation for enhanced seismic hazard assessment. And this finding attracts a critical gap in seismic hazard analysis for the northern Vietnam, offer a blueprint for data spot region, incorporating the HOV spectral ratio proved to be a reliable alternative for region lacking a VSLD measurement. And I would like to thank Academic Sinica and National Science and Technology Council of Taiwan providing me the funding, and Vietnamese Academy of Science and Technology providing the data to accomplish this study. So thank you for your attention.